All right, let's set up hardware for a GPS, a serial GPS, and a network echo sounder. So under the hardware program, I don't have any multi-beam going on, I don't have any side scan, and I don't have to synchronize my clock. So far, so good. Under the boat, I'm going to add my two devices. So the GPS, all right, if it's a NEMA GPS, I can just reuse the GPS DLL. And then I'm going to say I have a Teledyne Odom Mark III. So I'm going to add that device. Do it by description. There it is. So I have my two devices, and you can change the name of the device. So if this was a Trimble 461, right, and this was just an Odom CV3, you can shorten the names. And that's what they're going to be referred to in the survey program now. For each device now, right, I'm going to specify what am I going to use it for, right? Well, we're already going to record the raw data from the information from the system, but I could record the raw datagrams, but it's not going to help you do anything. Position, yes, that's why we bought the GPS. Depth, no, unless you're going up and down the mountain and using the ellipsoid height as elevation. Heading, if it has a directional antenna. Otherwise, it'll use the course made good. Speed, good boat speedometer. If you're going to use it for RTK tides, I'm going to have to tell it, yes, start that up. Record device-specific messages records information about the time sync and is only needed if you have problems with time sync. For my echo sounder, right, it's just an echo sounder. I don't have a heave pitch roll device coming through it. Under the options, paper annotation, yeah, if you want to send messages to it. I could also update a matrix with the depth information, but it's not very valuable for a single beam. Each device also has its setup. So for the Teledyne Odom system, let's say we have bathy data, we could have high frequency on channel 1 and high frequency on channel 2. If it's a single frequency system, we'd set it up like this. And then for the annotation, there's a couple of different options. The GPS has the most things you have to worry about when you set it up. First of all, are you going to synchronize to UTC? If the answer is yes, do you have a 1 PPS box? And then graphing the synchronization values is always a good idea if you're time syncing. If you're doing RTK tides, what's the minimum status to do it? It's only appropriate for RTK fix, but we can fix it afterwards. So if I was doing RTK tides, I'd say any status. And I would never filter the RTK tide unless I'm on a dredge. For the alarms, I could say, yeah, if the H-stop goes above 4, let me know. Number of satellites drops below 5, I want to know. And I'm not syncing the clock, so I don't need to set an error there. I don't have a second GPS for a baseline. And the age of my differential corrections, yeah, if it gets over 15 seconds, show me an alarm. I'm going to keep logging the data even through the alarm status because I can always fix it in post-processing. GPS status codes, almost every GPS made in the last 5 or 10 years is NEMA 3.0, so it differentiates between RTK fixed and RTK float. And you could show an alarm if you drop out of certain statuses. Then under the Advanced tab, what messages do I want to process from my GPS? Well, the GGA has my position, my GPS status, the ellipsoid height, that's always a good one. GSV allows me to do a sky plot. GST has the standard error information. I don't know what a GSA is, and my GPS doesn't put out a PNTLQA message. VTG is the speed and heading, and the HTT is the direction. So I'm wanting the GGA anywhere from 1 to 10 times a second. If you're outputting the ZDA for time sync, 1 Hertz and 1 Hertz only. VTG, maybe 1 Hertz. HTT, probably the same rate as the GGA. Down below here, if I was passing the GPS through an echo sounder, I'd have to know what the echo sounder was because they put different prefixes in front of it. But we have a separate feed. Everything else, no. Now for the survey connections. Let's take our GPS first. Let's say it's a serial connection. So up here, I'm going to go ahead and say, all right, what serial port is it? It's COM4, 9600, none 8 and 1. Good. That has to be correct, otherwise you'll never see the device. For my Odom, well, that's going to be a network. It defaults to UDP, reading on port 600, writing on port 601. That's the default settings. If you wanted to change them, you could come in here to the network settings and play with them. But they should do you right. You could then test the device. In the network test, I can ping the device to see if it's there. Well, it's UDP, so it's always not going to find anything. But I don't have an echo sounder, but normally it would be green, and then I could UDP connect. For the GPS, I could test the device. I don't have a COM port, so nothing good's going to happen here. Take 1 second. Here it goes, and nothing, because there's no GPS. All right, finally under the offsets, where are the items located on my vessel? On a small boat, I'll typically put my boat origin directly over the single beam transducer. And I'd like to put my GPS antenna over top of it. So if there's a rotation error, I don't have to worry about an offset. But let's say we're vertical, positive downward. So if we're 3 meters up in the air, -3. And then for my ODM CV3, starboard and forward, if we calibrate it with a bar check, then the static draft is incorporated right into the sounding. It's as if the transducer was on the water line. So my vertical offset would be 0. If it's outputting the depth below the transducer, then I'd enter in the static draft here. If I found I had a latency between my two devices, right, I'd enter the latency under the GPS device. That's how I'd set it up for a Trimble, right, or for a GPS and a single beam sounder.